so now that we've gone through a basic problem with expected value, let's go ahead and try a more advanced problem. So let's assume that I operate a lottery, and I want to find out how much money on average can I make when I run this lottery. So let's assume that our possible payout values are $100 if for the grand prize, $10, $1, or 0. Basically, you don't win anything. If I charge $2 for each ticket, I want to find out, on average, how much money do I make overall per ticket. So what we need to realize is that if I end up paying out $100, in order for the customer who bought that lottery ticket to get that $100, they had to first pay $2 to get that ticket. That means really, they're not really getting $100, they're actually getting $98. And then obviously here at 10, they're also only getting $8 because again, to get this, they had to pay $2 to get the ticket in the first place. So to show you how that works, Matt is going to explain visually how this works. So Matt comes to me as a customer, comes to the lottery. He wants to buy a lottery ticket. So he's going to pay me $2 for the lottery ticket.
I'm going to win. I got this shit locked up.
$2.
$2.
Alright. Here's $2 and I'll give you a lottery ticket.
It's the winner right here.
Okay, so for now I can pocket this. So what's going to happen is he's going to scratch off those numbers and he's going to find out what he wins. So let's go through each of these scenarios and figure out what happens. So in the first scenario, let's say Matt wins it big. He gets $100, right? Well, he still had to pay me $2 in order to get that ticket. So my loss there is negative $98 to Matt. Congratulations. But then let's try the other side. So here's your $98.
That's right.
But then in this situation here, Matt only won $10, so my loss is actually $8. And then right here, again, Matt had only won $1, so my gain in this example is $1. Because he paid $2, only got back $1, that means I kept $1. And then finally, in this situation where Matt wins nothing, he goes home empty-handed, and I gain $2 for that ticket. So now that we understand what our possible outcomes are, and this is what you need to identify first, or what your possible outcomes are, we can label these values that we found here as the x values. So this can represent x sub 1, x sub 2, x sub 3, x sub 4, and we can start seeing how we can fill out this, this formula. So now let's go ahead and assign some probabilities to these. So as the lottery owner, I'm going to try and calculate certain probabilities to figure out what is the appropriate balance. So let's try and put in some probabilities here. So let's say the probability that big X is equal to little x. That'll be our next column. So for this one, we'll do 0.001% of getting the $100 payout. We'll do 0.01%. Sorry, this is 1%, this is 0.1% for getting the $10 payout. Let's do 50% for the $1 payout. And then the remainder, since we know that all of these need to add up to 1, this last number has to be 0.489. Good. So now that we have the x values and the corresponding probabilities to go through each one, we can just go ahead and plug into the formula. So what we do is we just multiply straight across for each of these. Now remember, these two are negative numbers, these two are positive numbers. And this is from my perspective. So I lose money here, but I gain money here. So our third column will be x times the probability big X is equal to x. So this times this gets us negative 0.098. This times this gets us negative 0.08. This times this is 0.50. And then this times this is 0.978. So these are the individual expected values. And we know that at the end we have to sum them. So finally, our answer is 1.3. So now we have to interpret this answer. What does this answer actually mean? So this answer here is the gain that I get per ticket on average. So if you were asked what is the interpretation, you would say, on average, if I were to perform this experiment many times or an infinite number of times, I can expect to gain $1.30 per ticket that I sell. So that is how we do a little bit more of an advanced problem. But Matt Guthrie is going to show us another way to answer this same problem.
So I have another way of looking at the problem, and it really just relates back to how you end up defining X. The way Ashish did it, he defined X from the lottery's point of view, saying if he runs the lottery, these are the payouts and what he will gain. Now, if we go ahead and rework the problem from the perspective of the the person purchasing lottery ticket, or me from the example because I paid $2, but I want it big, we can look at our payouts differently. So the way I could look at it is I could look and say, I'm going to define my X value as what I can win. So I know that every time I'm going to have the the chance of winning $100, $10, or $1. Now, I know that I'll have to pay out $2 every time, but we'll get to that later. So we're going to add in our probability of successes here that relate to everything to fill in our table, and then calculate those out to get our expected values. So let's do that real quick. We had 0.001 here, 0.01, and 0.5. So I'm going to multiply these across just so we can get the numbers out. This one will be 10 cents, 10 cents, and 50 cents. So now if you've been watching previously, you'll know that the probabilities don't add up to 100%, and we also are missing an X variable. That's okay in this instance, because what we're going to do is we will add up all of the positive payouts and then subtract the negative payout in the end. So to show you how that works, when we sum this, we'll end up getting 70 cents of profit. So I'm kind of happy with that because I know that on average, after many times of this experiment, I'll get 70 cents per ticket. But every single time I get this 70 cents, I have to pay in $2 to get it. So I have to come here and subtract this $2. So on average, I am losing $1.30. So we know this works because when Ashish did it, he was gaining $1.30 and the numbers work out. So if you have trouble seeing it from one perspective, you can go ahead and look at it the other way. It does work, just do whichever is easier for you.